Thank you so much for coming. यहाँ सबैलाई चाहिँ म हार्दिक स्वागत गर्न चाहन्छु। हाम्रो आजको स्पिकर चाहिँ प्रोफेसर मिम लाल नकर्मी सर हुनुहुन्छ सिटी युनिभर्सिटी अफ न्युयोर्क ब्रुकलिन कलेजबाट। उहाँको धेरै इन्ट्रोडक्सन छैन के भनौँ। ल मिम सर, द फ्लोर इज योर्स। थ्याङ्क यू सो मच।
Thank you. It's nice. Yeah.
Display. Great.
Okay,
Yep, good. Thank you.
Thanks. Okay, so thank you for inviting me in this NPA program. And today I'm going to discuss about my experience in scale-up environment when I was teaching undergraduate level physics at Brooklyn College. And I will also share my experience because I started this program at Brooklyn College, and I also designed lots of class material, course material for General Physics 1, Algebra-based Physics, General Physics 2, Algebra-based, and also Calculus-based Physics. And also you can stop me anytime if you have a question, we can have interaction. You don't need to wait at the end if you have any question or any confusion. All right, so this is my title, and then teaching experience. All right, this is my outline. So as I said, I was involved in implementing scale up at Brooklyn College. And I will explain what is scale up in our general sense. Scale up means we like to produce or we like to do something in a big volume, right? So this scale up also has this similar meaning, but it also is the abbreviation of one full sentence. I will explain all of them. And why scale up is important, and why is this good for a student, instructor, and college, right? So all these are based on my experience, and I'm not from the physics education research group, but some of the data I collected might be useful or could be something like a result from physics education research. All right, so let's keep going. It's getting slower. All right. So scale up is related to active learning. And what exactly is the scale up? Let me keep it secret for a few seconds or a few minutes. So this is about active learning. And then active learning is for all of us. If we are involved in teaching, or even we are a student at this moment, and we could be also part of the administrator, and scale up active learning technique and active learnings teaching are related to, or they are good for all these three parties. So one is student, another is instructor, that's we, and another is administrator. So what we need in the for student, good things for student, we like to have a better understanding and gain more knowledge from physics. And it is not only for physics, this technique can be also used for any other field. And for instructor, when we teach somebody and when we see students learn from us, we feel happy. And after we teach, when we come back with satisfying experience, that's what we want, right? That's what we like to get. And as a teacher, we don't get lots of money. But teaching satisfaction, job satisfaction, that's what we like and we want. And active learning will give that. And for administrator, they like to have some better data points Those data points are related to, we call DFW, D grade, F grade, W means withdraw. Some student could not complete and they withdraw in the middle of the semester. And also we like to read, those are related to retention and graduation. So administrator always like to see when students register in a course, they don't like to see students drop. They don't like to see students get failed. They don't like to see students get bad grade. So they like to improve. So active learning helps for all these three parties, but it doesn't come as a free. And there is always responsibilities for all these three parties. For the first, students, since I said it is active learning, and student needs to be involved actively. So that's why it's active learning. And for instructor, it's not like a regular teaching schedule or teaching habit we used to see or we used to do probably. And in this active learning, instructor need to spend more time outside the class, design the class and develop course material. So someone cannot simply look at the old notes 20 minutes ahead of the class. That's not possible in this active learning. And for administrator, they also don't get it for free. They have to invest some money for development of infrastructure, development of the material, development of the classrooms, right? And also need to buy some instrument which is suitable for the active learning techniques. So I was involved in the scale up from spring 2010, and I started first algebra-based general physics 1. And after that, even for the first time we started that, I designed lots of course material because it involves hands-on activities, different kind of lab activities, and group cooperative group problem solving, collaborative work, quick feedback quizzes, lots of stuff. And after that, once we implemented, we revised that based on the students' feedback and the instructors' feedback. And after 2 years, I started for General Physics 2. This is also algebra based. And same thing I did, I developed the materials, I designed lots of hands-on activities, group work. And after that, I also implemented this for the calculus-based physics in 2018. And I also co-taught with other instructors in my department, and some of them are now teaching in the scale-up. All right, so before I start actually this scale-up things, let me ask one question to everyone, and you can type your answer in the chat box. So my question here is, because this is active learning, so everyone has to be involved actively. So I just want to check how many of you are actively involved right now. So my question here is, when did you learn or understand the subject matter? Learning meaning basic understanding of physics or maybe any other subject matter the most, right? Which one is the best answer for you? Or you can put your answer in the order which is the most accurate, and then put that in the order to the least one. So when did you learn, right? When my professor taught me in the class, when I interacted with my professor, when I interacted with my friends, when I worked out myself, when I started teaching. So when did you learn, or when did you understand the subject matter? Okay, so let me okay, ED, DE, DE, okay, EC, A, B, D. All right, so I see most of the answers. So I think in the answers, let me just I think consistent answer is there is, I guess, only one person said when my professor taught in the classroom. And in most of the answer, the most accurate are either D or E. When I started teaching or when I work out myself. And some of them are when I interacted with my friend. I guess the conclusion is the A, when my professor taught in the class, is not the most accurate answer. Okay, so all right. So some of us are teaching, and we just said that we do not learn when professor is teaching in the class, then what we are doing in the class to teach our students. We just said that, and that's our experience, and from also the sampling survey, when professor teaches in the class, students don't learn a lot. There are other methods like when we teach others, when we learn by ourselves, and when we discuss with others, we learn better. Then why should we teach in the classroom? Why don't we use those techniques where we learn better and where we understand better? Okay, so if teaching by professor means that's the lecture, meaning the lecture method is not actually a good method for learning. Good method of learning is when we teach others, right? And that time we have to study ourselves and when we discuss with others. So can we have a classroom where we can teach others and learn, where we can discuss with others and learn, right? So, and then let's reduce the lecture. That doesn't help you learning. So for that, what kind of classroom we have to make? So that is all about the scale up. All right. So full meaning of the scale up is student-centered active learning environment for undergraduate program. So this is first developed by Bob Beichner at North Carolina State University. Right now he's a retired physics professor. So he started this for physics program from NSF grant, and then after that, once it is developed, and this technique is also used for not only physics, also for other science, including engineering, computer science, and then they changed the name. In the beginning, it was student-centered active learning environment for undergraduate physics, but this is only for not only for physics. It can be used for any other program. So they changed the name undergraduate program. So, but it is still scale up. And the meaning of this, the scale up also has the real meaning of the scale up, meaning this technique can be used for large enrollment courses. So normally the impression is if we teach in a small classroom, we can teach better. But if we need to teach for large classroom and still teach better way, then this is the right way. So in that sense, it has also scaled up teaching for big volume or large student number in the same classroom. In some universities or colleges, they even put more than 100 in one classroom in this technique. So scale up is in this is very short definition. Scale up is an environment. It's a classroom environment, and it is to establish a highly collaborative, hands-on, technology-rich, interactive learning environment for large enrollment courses. All right. So what we like to do in scale up is, oops. What we like to do in scale up is we like to change the teaching mode from this mode, which is the lecture mode, to this mode where students are actively involved in activities or in the learning process, but the instructor is sitting behind and helping them if they need. Okay. All right. So why does the scale up work? It is because scale up is active learning technique. Meaning in the scale up in this environment, we can easily implement active learning techniques. Scale up itself is not active learning technique. In the scale up environment, we can include or we can adopt active learning techniques. And why does it work? These are all kind of learning activities. We can learn doing real thing. We can learn some by simulating. We can also learn by looking at demonstration. We can also learn by reading the books, right? So this is called a learning pyramid. And if we do these activities, this is from some research results. So if you do some of these activities, and after 2 weeks, we tend to remember only 10% if we read a book, right? And these are called these techniques like books, reading books, listening to lecture, looking at the transparencies. These are called passive learning. And also, if you just look at the exhibition, if you just look at the demonstration, students will say physics is fun. Oh, that professor did some demonstration that looks very interesting, but I don't remember what he was doing. But I remember he was very funny. They will remember that way, but they don't remember the knowledge we like to teach them. So simply demonstration is also passive learning. But once we start discussing and explaining to others, and once we involve in some activities, then this becomes active learning. And that tend to remain or remember almost 90%. So that's why we like to do more active learning techniques. So difference between active learning and the passive learning is, passive learning is we use our sensors. For example, if we can look at something by our eyes, we can listen with our ear, right? We can just use our sensory organ just one way. And in the active learning, we get some information from our eyes or ear or something, then that needs to be processed in our brain. Then after this process, if we express it, right? If we express it, that's the active learning technique. If we just listen, if we just read, if we just look at, so that is not active. That's all are passive. So that's why it is called, we hear this proverb, tell me I will forget, show me I may remember, involve me and I will understand. So involvement of any activities, and then ask question, process that in our brain, and once we process, express it, meaning talk with others or write something and do or explore on other things, and that's the active learning, right? All right, so let's go a little bit in detail. So in the scale of environment, I'm again saying scalar environment is a classroom. Inside that classroom, we can easily implement active learning techniques. There are lots of active learning techniques. I will also discuss some of them. and it has to have interaction. It could be some innovative techniques, and in this environment, students work in group. So when they work in group, they discuss with others, they teach others, they learn from others, and also some of the problem they cannot solve, they can solve when they work in the group. Okay, and then next is, in this environment we can also use or add any technology rich stuff. For example, you can include laptops, internet, audio, visual, whatever you have. Use cell phone as a clicker, whatever, any technology things develop, new development, you can include easily. And this environment also should give regular feedback so that we can improve our course material, and also change our course, or maybe teach in a different way. Sometimes same technique doesn't work for all groups. So you might have to change quickly, or maybe for the next semester. And another feature is, this is a studio style class mode. So studio style class mode means it is the lecture, recitation, labs are done in the same place. So most of the time when we teach physics, lecture is done in one place and then lab is done in another place. They don't go together. And students think lab is lab, lecture is the physics. So lab is we have to do and get this done, forget about that. You don't have to learn anything. You just have to write the report and submit it, that's not. But that's not what it is, right? We have, since we know physics. So this should go together. And most of the time labs are scheduled in the beginning of the semester, and they have to go in that same way. If the lecturer is going behind, we have to teach the lab ahead, and most of the time students don't understand. So in this class, they go together synchronously or correlated, because they are all doing at the same place. And another important point is, we don't use lots of time for lecturing. As I said in the beginning, lecture is the worst teaching method. So let's reduce that, and let's add lots of activities, hands-on activities, so that students can involve, they can do work together, right? And also they also have to learn writing, scientific approach, all these things we can do in the same environment. All right, so if we reduce the lecture, then how do we teach some concept, right? Even to learn new concept, we can design the activities, hands-on activities, maybe ask question, maybe do some activities, do some play, right? So that's where instructor has to bring some innovation to teach some new concept without lecture. And at some point, we also, it doesn't mean lecture is zero, because sometimes students can complain, this professor doesn't teach anything. We have to learn everything in this class, so this professor is useless, right? So we also don't like to hear that. All right, so how did this scale up goes? And if we like to include all those features in that classroom, how should be the classroom, right? So definitely we cannot use the regular lecture hall where students are sitting in the parallel, and the last bench you cannot approach last bench, and we can also approach, or you cannot hear anything. Somebody even asks question from at the corner, meaning there is no interaction with student and instructor. That environment is not good for, that's not a good environment in a scale up. So before I go to real scale up environment, in this environment, in the picture, this is a banquet hall. So what feature is good in this picture? there are lots of things. It has a round table, right? It has lighting. It has also plates on the table. So what did you like this in this picture or in this environment? Chatting environment, right? That's correct. If you go to a restaurant which has this kind of a round table, and then people in that round table and also people in the another round table, normally there is no disturbance between those two groups, right? But everyone in that group can hear what you're talking, and they don't actually disturb that much to the other group, right? So that is the best feature of this environment. And can we use this? Can we use this for scale up? Can we use this environment for college, teaching the college level courses? This is actually the scale up classroom. So it's a real, this is the practical design of scale up. So as I say, scale up is the environment. And in this environment, classrooms are different than our regular classroom. So it has round tables. And this round table is designed, best optimized diameter of the round table is 6-meter diameter. They also design different size, and they found the optimized size is 6 feet, 6 feet diameter. And in one round table, 9 students, one table for the 9 students, and 9 students are divided into 3 groups. So each group has 3 students. One round table, 3 groups of 3 students. So 9 students in one group, one table. There are 3 groups, and those 3 groups work separately, and those 3 students work together. So for those 3 students, we provide one laptop, and all the lab work, hands-on activities, group activities, cooperative problem solving, everything is done in the group of 3, and there are 3 groups in one table. So based on size available, right, you can add as many tables you want, and that's how it is scaled up. And here there are lots of also whiteboards around this classroom, and there should be definitely there is a Wi-Fi, because internet should be available. Everyone has access to a laptop, and some students, they also use cell phone for not for other purpose, for this technique as well. And these whiteboards and the projectors are displayed all around this classroom. And instructor does not lecture like in our regular classroom, right? So how do students learn in this environment? So they are sitting together, and three students are working together in a group, and here is the professor, and another is TA, and they should have already designed the classroom and group activities, everything what to do ahead of the time, and students are working together to complete those tasks, and that's how they learn. And if they have any question, a professor is there, one TA is there, and they can go anywhere, and this is, instructor can reach to everybody. And also it should have any equipment for the hands-on activities, and also laboratory equipments They should be easily accessible. In some places, they design the classroom, they put all the instrument around the wall, behind the wall, and some people use underneath the table. Sorry. Oops. Okay, underneath the table, and it also varies some place to place. So the upper picture is from Ithaca College, it's also New York, and lower one is in our Brooklyn College, and the one, this is me. So I was also walking around and looking at students, what you are doing, what you are learning, and if they have any question, they can also ask other group, and we encourage first to discuss together in the group, and if they finish early, they can help other group. And there is always one TA and one instructor ready for answer any question. And the approach here is not to teach directly what they need. The approach here is exploratory. If they like to learn something, let's try this way, right? If they ask question, don't answer the exactly what is the answer for that question. And we normally develop based on what's their understanding level. So if they ask something, then we can ask them, do you know this? So if you know that, how do we change something, right? And then slowly develop their knowledge, exploratory knowledge. And then after that, okay, if you know that, if you know this one, then think about change one parameter. How does it go? So we don't answer directly what is their question, because we like them to learn something in their future, and whatever they learn may not be applicable. But if we give the way to learn something, that may be the best asset for them. Okay. All right. So when we teach scale up, we use the same textbook. We use the same time in our college. In the traditional section, there are 2 lectures, 2 times a week, and 1.5 hour, 1 hour recitation, and 3-hour laboratory for one section. So total is 7 hours. And we use the same time, 7 hours, but we teach twice a week. So each session is 3.5 hours, 3.5 hours. So students are in the same classroom for 3.5 hours. If we teach or if we lecture for 3.5 hours, everyone will sleep, right? So this is not for lecturing. And in my experience, students don't get bored. They don't even realize that they spend 3.5 hours in that classroom, because they are always actively involved, and they need to finish something, and they are also talking to others. So we don't yell our students when they talk to others, only in scale up. In other regular classroom, if someone even look at others, and then we have to watch them and alert them that don't disturb in this classroom, right? But here, if someone is sitting there doing nothing and keep quiet, and we have to ask them why you are not saying anything and why you are not doing anything. So that's the difference. So only the difference here is it is a different teaching method. So one understanding or one conclusive understanding, and so far what we learn from physics education and also other education research is, it is not the professor, right, that makes the best teaching or learning. It is the method, it's the technique. It doesn't matter, it doesn't change that much. If it is taught by a very renowned professor, you may be impressed or may learn a little bit more, but if it's the average, it really doesn't change that much. But if you change the teaching method, then the outcome or the understanding or learning difference will be huge. So that's what everyone agrees now. So in the scale up, we provide lots of hands-on activities. We make the activities to work together. That activities could be problem solving. Those activities could be hands-on activities. Those activities also could be playing in a simulation, computer simulation, right? Those activities could be also laboratory. So those are done in group and they are working together. It's not only in the classroom, they can also work together outside. I encourage them to work together. They also write the report together. That way they learn. So another reason they learn when they work together is when they speak at the level of their language, and also they speak their language, right? They can easily understand their language than instructor or professor's language. When they listen to professor, they think professor is teaching too much technical word, right? Professor knows a lot. He knows a lot, but I don't learn anything from him. That's not what we want. But when they learn, I mean, they talk together, they are talking at the same level and they learn quickly. All right, so, and then one more thing, lecture is significantly reduced and students are divided in group of 3 and it has to be done carefully. Meaning 3 students, I spend some time beginning of the semester who should be in that group. Normally, if I put all ladies in that group doesn't work. If I put all the guys, boys, or then that group also doesn't work. And in New York, we also need to look at ethnic background. Sometimes Jewish people, Muslim people, it is difficult to get together, right? And also, if we put two ladies, right, and one person, one guy, and those 2 ladies put aside that guy, so that also doesn't work. And sometimes when we put one smart guy in that group, he does everything quickly, right? And other students, another 2, they are very happy because they don't have to do anything and it's done. But they are not learning anything. That's also, we don't want that to happen again. And some students come back and say, why do I have to teach others? They don't study or they don't spend any time at home, but I have to spend describing others. Why do I have to do that? And then I repeat the same thing. When you teach others, you learn more. I'm learning even now. I learned this course long time ago, and I'm teaching, and I'm learning more and more. So if you teach others, you will learn more. And most students convinced with that. All right, I think I'm almost done. So as I said, we can implement active learning methods in this environment. So whichever the activity learning methods you like to implement, for example, hands-on activities, interactive lecture demonstration. So simply demonstration is not active learning method. It has to be interactive. So I will give you one example at the end. And cooperative problem solving, this is all group work. And team-based learning. So there is also team-based learning, TVL. This is same principle developed from same principle of working together. Peer instruction. Right? Some of you have might have heard about this peer instruction by Eric Mazur. And think, pair, share. Right? This also involves that active learning. First, listen problem, right? And then think what do you think about that problem, how to solve that, and discuss with your friend, peer it, and share. So once you think and then process it and then share with others, that is already involved active process. We can use the simulation-based activities in the classroom, can be made as a group or maybe use as an individual and then come out results in the group. So lots of things. It is not only this. We can maybe there are lots of things are in the development. So this environment provides the platform to use them. Okay, so in my class, typically in the beginning, there will be either a quiz or short lecture to discuss about what is the new concept we are learning, or to summarize what you have learned. And then after that, for most of the topic, based on the topic, I have designed some activities, hands-on activities. It's kind of it could be kind of short experiment, right? Small experiment, and then they can really see what's the result, and they know, oh, that's what it is going on. And after that, sometimes we discuss the results from the activities and summarize that. So this summary also part of the lecture. And problem solvings always work together, and they are all in the group work, and some of the groups can also make presentation, like we have 3 problems I assign, and out of those 3 problems in the same table, I can give 3 different problems to solve by 3 groups. Once they finish solving that, they can share with others. So that way 3 problems are done at the same time. And laboratory exercise are slightly different from our regular lab, because most of the lab manual in physics now are written like detailed instruction. First do this, and then after that record this, and from that number multiply this, and you get the answer and find out what is the percentage error. It's like a follow the recipe to make a good cake, right? You will make a good cake by following the detailed instruction, detailed manual, but it may miss what we like to teach them. They may get a good answer, they may get a small percentage error, but that is not what we like to teach in physics. We like to teach something, some knowledge. It's not fill up the tables and get the answer. So for that, I wrote most of the labs without details. So what we tell them is, we like to do this thing. So how do you think we can do? Think about. I will give you everything what you need. Just design what you think you can perform that experiment or to get that number, and I will provide whatever the instrument, whatever the material you need, I will provide that. So they can design their own experiment, or otherwise I can give some hints. Most of the time I give some small hints, and then I also don't give the table to fill up the data points. So based on what are the numbers you get, make your table on your own. So if we provide the table, they can use that, but they will never learn how to make a table to collect the data. And I use this concept test and ILD, interactive lecture demonstration. All right, so So other things are similar to regular lectures. We have also 3 midterm exams, final exams, but we have more quizzes. So these quizzes, classwork, like class assignments, those we cannot use in the regular classroom, otherwise it takes lots of time. So these are additional components. And one other thing is we ask them to write a report, combined report. But they have to share which part will be done by whom, and they have to rotate the role. And after each midterm exam, I change the group again. Some people don't believe that we should be changing, but in our physics and based on my experience, if the same students are in the same group for more than one month, they don't talk about physics. They start talking about Facebook. They start talking about something else, right? So it's better to change the group, and that way they also know their friends. Their friend actually this is good for maybe good for their career in future, for making network. So when I teach in the regular classroom, most of the students, they don't know each other. They know maximum maybe 2-3 students. They don't even talk to others. But in this classroom, since I reshuffled the group, they almost know each other. And I always tell them, when you become a doctor and when you become an engineer in future, when you meet together, definitely you will talk. And at that time, don't forget me. Talk about me too. All right, so let me give you one example of these activities I designed. So this is also some material I adopted from somewhere but modified for my class. So most of the time when we teach the electric circuit, most students think that electric circuit is like irrigation. So it uses electric current. That's why we get the light. And if we don't, when we turn on the light bulb, it uses some electricity current, and then remaining will go back to the battery. Right? That's one concept. It makes sense, but that's not true. And so before I teach electric current, I ask them to do this activity. I provide the battery, I provide a light bulb, provide a meter, ammeter, and then also ask them to find out what's the direction of the current flowing. And there are 4 possible ways, and they will test which one is correct. This gives the direction of the current and also quantity of current. How much current flows in one path and how much is in the return path. Is this really return? Are the current going from positive terminal and negative together to the bulb, right? Or maybe current is flowing and there is some current is used, remaining will go back. That means the returning should have the less current. So they test all of them and then they figure out, oh, this is the one actually current is flowing in a circuit. So after that, when I explain, they understand clearly. After that, we do some discussion, summarize what's the understanding from this activity. So this is one, and then another is, by the way, I said there are lots of whiteboard around the classroom, and those whiteboard they can use to work together. This is easy because sometimes when they write down and someone say no, that's not correct. So if they are working on a board, they can easily erase and then correct it instead of writing on the paper. And also when they work on the blackboard, once they complete one and then I stop them, okay, leave it there, and then I ask other groups to look at, okay, that's the correct answer. So they are teaching others. All right, I think I already went through most of this. All right. So when we developed this scale up, our college invested some money to change this classroom and for all these furnitures and also different sets of this mostly vernier equipments. So we spent like 200,000 equipments for physics 1 and another 150,000 for physics 2. In the first time we have to buy lots of stuff including laptops, vernier, lab quiz, right? So it was a little bit more for the first time. But once it is spent, and those most of the physics stuff they last for more than 10 years. And another is I used most of the time, it's called the interactive lecture demonstration. I removed the lecture because we don't like to use lecturing. So as I said, simply demonstration is just the physics is fun. It doesn't teach physics. It has to have an interaction. So for example, in the interactive lecture demonstration, there is one activity. And that activity is explained by the instruction what he is going to do. He will explain, I'm going to do this. Now, if I turn this on, what will happen? Without turning on, we ask them to the student and they have to predict what will happen based on the knowledge they have, right? For example, I have here a cathode ray tube, and cathode ray tube electron beam is coming here, and here is we have a spot here. And then my question is, if I bring the north pole on from this side, where does the spot move, right? Now they have to think. Electron beam is coming, they have to use the right hand rule, and north pole is coming here, so what's the direction of the magnetic field? And it is a negative particle. So based on that, they will put their answer on the paper. They have to write down. So after that, I will really perform the activity, and they see the real result. And once they see the real result, and if this is correct, that makes sense to them. And if it is not correct, and they will think why my answer was not correct. And sometimes we ask some students to explain that. And if it is too complicated, everyone got mistake, then I explain that. So that way they have to first think and predict that and see the real result. That's the final answer. And they have to learn and they have to understand why it happened. And another technique I use, this is from TBL, team-based learning. So most of the time I use this for concept quiz. These are actually multiple choice question. So I have one question and there are 4 choices, right? And those 4 choices, they give the answer from this scratch book. So for each question, there is a correct answer, and for the correct answer, it has a star underneath that scratch. So they have to scratch like that we get a code from gift card or something. So there is a star underneath, and once they answer, they have to scratch. Let's say they answer C, and they have to scratch C, and if they see the star, then yeah, right? That's the correct answer. If not, then that's not correct. Now he has to scratch another or think again. So once, if they get the star, correct answer first time, they get 4 points. If they get a star in the second time, then they get 2 points. If they get a star in the third time, they get 1. It is actually 1. And if they get the star in the fourth, it is obvious, right? They get 0. So they have to be very careful scratching that. If it is not correct, they are losing 50%. right, consecutively. So first they take this test individually, and after that I collect that this scratch sheet, and then I give the same quiz or questions in the group. Now they are working in a group with the same question, and so in the group they discuss together. Some of them made correct, some of them did not correct, or maybe most of all of them did not make correct. And then once they discuss together, oh yeah, I was wrong, yeah, that you are right. And they say, no, you are not right. So they discuss together and finally come up with one answer, and again they scratch it. So when they work together, their score is definitely higher than individual, meaning they are learning when they are discussing together. So that's the one technique from the TBL. TBL is different active learning technique, and I use this in the scale-up environment. All right, some of the results I have here, assessment kind of to prove that to data point to prove that what I'm doing is better than the conventional class. So what I did is I used the scale of force concept inventory. If you don't know that, this is a set of questions prepared by physics education groups, and these are called some sort of standard set for the assessment. So there are I think 35 questions in FCI, force concept inventory, and in the conceptual survey of electricity and magnetism, I think there are 30 students and 30 questions. So these questions I give in the beginning of the semester before I start the class, and also I give the same question at the end of the semester, and then measure, meaning pre-test and post-test, and full score minus the pre-test, right? So some students may have done already better in the beginning. Some may be very poor in the beginning, but compared to that level, at the end of the semester, how much they have improved, right? How much they have improved. So that quantity is the gain. So I calculated the gain for all of them, and then these are the result of these different groups. And also I gave the same question, similar survey question to our regular conventional class. It's not only one time. I give for few times regularly, and then these are my results. So this is for physics 1100, and this is for physics 2100, physics 2. So compared to traditional, right, compared to all the time, scale up has higher gain in physics 1 and physics 2. So these questions are actually conceptual questions. So based on that, I can definitely say students in the scale up have better conceptual understanding than this our regular class. And also I did some of the further analysis, like out of those students, right? I put them together. Some of them are this high, medium, low means their grades, based on the grade, and average gain. So what I'm trying to say here is, who is actually making more gain? Is that the poor students, they are learning more, or good students they don't need to learn more? They are not learning more compared to the beginning. So based on these results, you see high are the one who has the higher grade. They have higher gain. And also middle also has more gain. Meaning good students have already learned more and they don't have to learn anymore. That's not true. They also learn more in this scale up. And a few more. One, what I did was, that was a conceptual test. That has nothing to do with grade. Meaning the conceptual test I did, FCI, that doesn't count towards the grade. Grade are based on the quiz, test, right, exams, and then we award the final grade. So some people may ask, because we give most of the time problems for the exams, and are they learning problem solving techniques? So what I compare here is grade distribution. So when I compare the grade distribution, this T8R is the scale up section, and this T6 and M9, T6 and M9, they are our regular conventional class. So if you look at the grade distribution in scale up, because good students are learning better, medium level students are also learning, so they are also improving. In some cases, it almost like a good students. So we get more A's level. Sometimes almost half of the students get A level. A level means A minus, A plus. But if you look at the conventional, most of the time either B or C group, C grades are, number of students are more. So these are the sections. Scale up is I taught and others are taught by others. And one section, this one is I taught scale up in spring, and then I taught in the conventional class in fall. So this result is based on, sorry, this result is from students taught by me. Another was scale up I taught and other groups are taught by others. So even here, scale up has a grade distribution. If you look at the grade distribution, there are more A's, small B's, and even small C's. And there were some withdraw, W, and in one time, this is just one time, there was no fail, and there was no D. But if you look at the same another group taught by me, there were few students A's, little bit more B, and lots of students who got C. So in our case, most of the time, after looking at 5, 6 years in our college, the DFW rate in physics 1 is, in the traditional, it's like 20% in physics 1, and it's 20% in physics 2. For scale up, it's like a half, 10 to 20%, and physics 2 sometimes zero, even zero, and maximum is 10%. So with all this, I can definitely say scale up works for students, and it gives me satisfying experience when I come back from the classroom. And I think our administrators are also happy with the students' performance, because they like to see higher retention and then higher grades, right, and lower DFW rate. Okay, so I will stop here. So, and if you have any question, you can ask me now.
Thank you so much, Mim sir, for this excellent presentation, sharing your lot of teaching experience in scale up environment. There are few questions here. One question is from Salikram Bhandari sir. What is the difference? What is the duration of time for one period? Can we complete our syllabus? I think the first question was already answered. The second question, can we complete our syllabus?
Yes, definitely. Definitely. We actually cover more topics than conventional class.
Okay, thank you.
But we have to utilize total time. So my experience is, if we use that, if we are teaching in a conventional class, in the lab, even the lab is 3 hours, some students finish in 2 hours, right? And they leave early. But here, we don't let them go, and we utilize all the minutes.
Yeah, thank you.
So that's why we are able to cover more topics than conventional class.
Nice. Next question from Krishna Mardhan sir is, what is exploratory lab activity? Probably that is already explained that like Mim sir, I think that question was asked earlier, but Mim sir showed exploratory lab activity. Next question is from uh, uh, Dr. Bir Bohra sir. The question is, in comparison to lecture method, did you compare outcome from this? Oh yeah, that is just answered actually.
Yeah.
Actually, that is just answered. Data is very reasonable for. Oh yeah. I think that. Oh, there is another question. I believe. How scale up method is different from flip method?
Flip method. I haven't used flip method. Probably Rudra might know
Yeah,
detail about flip
yeah.
method.
In general, like scale up memes are very nicely explained in 1 hour. Like that's fantastic. But flip is basically some material like flip is just a reverse. Like whatever you do in the classroom traditionally will go home, and whatever is given in home will be done in classroom. That is
Yeah.
flip. That is in simple language. That is the flip. That means problem solving and homework problems, those kind of things are done in classroom.
In the classroom.
Lectures are reviewed or done by students in home. So that is the difference. Another question here from again Dr. Bir Bohra sir. Are labs integrated with its lectures?
Not each lecture. Let's say there is no lecture, right? Maybe it's a class, each class. So we teach one topic, and it is based on the instructor judgment. Something we can teach by doing lab first. Sometimes we can teach better. They first get a concept and then do the practical, right? So it also depends on the speed of the class. So sometimes we are discussing, for example, sometimes I design, okay, at the end of the class today, I will give lab. But in the beginning, I gave some problem, and they took long time, and they could not finish their time, and I don't have time for the lab. And I can say, okay, we are going to lab next time, right? So lab is not pre-scheduled.
Great.
And when we put the lab, it's up to the design of instructor. And the instructor has to design those things outside the class. And instructors spend most of the time, I mean, we have to spend more time outside the classroom for designing those.
Great. Thank you, Mim sir. There is one very, very important question, because the goal of this program is actually like putting in this late hour, 10 p.m. is, of course, for this question. Priti Bhakta Adhikari sir asked how to apply this method in Nepal.
How to apply this in Nepal? Whenever you have chance to develop your classroom, right? And let's say you are doing something big change, then that's the time to apply this. When you make one new classroom, you definitely have to build furnitures, right? You definitely have to make your classroom. And when you do that, don't build those things traditionally. right, traditionally. Develop something that can be used together with the lecture, lab, and some activities. It doesn't have to be exactly the same thing like done in America. It could be designed suitable for Nepal. But definitely we have to invest something. And in the meantime, if you don't have the money to change right now, you don't have to do all the things, say all the things right now. There are lots of things you can also apply. For example, you don't have the round table. Round table provides to put students together, 9 students together and 3 groups together. But if you still have small tables right now, I think in most of the places in Nepal, tables are made for 2 students, not like our previous table, 10 students sit in a one row. So if you have that, you can join those 2 tables and make a group of 4, right? Start that way. And you can also implement, basic thing is we have to implement or use active learning techniques. And we are trying to change the classroom design of the classroom so that we can easily implement the active learning techniques. You don't have to use all the active learning techniques. If you can put 2 students together, right, work together, if not 3 students, you can start with peer instruction. You can start with think, pair, share, right? We can start with interactive lecture demonstration working together, 2 students working together. And if outcomes is better, then you can claim or you can request administrator. This is the way we have to go.
Great. Thank you, sir. I believe we have Sitaram Baut, sir. Sir, he has raised hand. Baut, sir, you have, is that right, Sitaram Baut, sir?
Yes, yes. Thank you.
Yes, sir,
Can I
please.
can I say something?
Yeah,
Yes,
sure,
please.
sir.
Yes, please, sir.
अनि नेपाली नबुझ्ने पनि छन्।
होइन सर, हामी सबै नेपाली बुझ्ने नै छौँ, सर।
ल त्यसमा नेपालीमा अथवा मिक्स्डमा भन्न सक्छु।
हस्, प्लिज, सर।
अलिकति यो एक्टिभ लर्निङ एक्टिभिटीसँग मेरो अलिकति परिचय भएको हुनाले म भन्दैछु। 2003 मा म पोस्टडकमा जाँदाखेरि मेरो एडभाइजरले यस्तै खालको सुरु गर्नुभएको थियो कोलोराडो स्कुल अफ माइन्समा। प्यारलली युएसमा 8-10 वटा ठाउँमा खास गरी इन्ट्रोडक्टरी फिजिक्स टिच गर्नलाई र पछि त्यसलाई केमिस्ट्री र अरू सब्जेक्टहरूमा पनि बिस्तारै इम्प्लिमेन्ट गर्न थालियो। तर अझै पनि युएसको सबै ठाउँमा इम्प्लिमेन्ट गरिया छैन। मलाई जानकारी भएअनुसार अब यो स्कुलमा पनि र खास गरी युरोपमा र साउथ अमेरिकाको ब्राजिल हो या कोलम्बिया हो, त्यहाँ एउटा लेडीले यो सुरु गरेका छिन् 4-5 वर्ष अगाडि। र इटालीमा अर्कै नामले, तर बेसिकली फिलोसफी यही नै हो, इन्टरेक्टिभ स्टुडेन्ट सेन्टर लर्निङ प्रोग्राम। र स्कुलमा यो हाइली सक्सेसफुल भएको छ। कलेज लेभलमा त्यति धेरै इम्प्लिमेन्ट भइसकेको छैन वर्ल्ड वाइड, तर युएसमा इम्प्लिमेन्ट बढ्दैछ हरेक साल र इट्स हाइली इन्करेजिङ। अब दोस्रो, अब यहाँ नेपालमा म आएपछि खास गरी मैले रातो बङ्गलामा त्यो बेला मेरो कन्ट्याक्ट थियो र अलिकति सजिलो पनि थियो, त्यहाँ अलिक प्रोग्रेसिभ भएको हुनाले, र मैले इम्प्लिमेन्ट गर्न खोजेँ। त्योभन्दा पहिले हाम्रै डिपार्टमेन्टमा पनि यसको सानो रूपमा मैले इम्प्लिमेन्ट गर्न खोजेँ र मेरो स्टुडेन्टहरूले सम्झला। मैले होमवर्क दिन्थेँ रेगुलरली, तर कसैले गर्दैन थियो। क्लासमा सायद मलाई मन पराउँथे या त्यति मन पराउँदैन थियो होला, तर होमवर्क र ल्याब वर्कमा म अलि स्ट्रिक्ट भएको हुनाले मलाई कसैले मन पराउँदैन थियो, विदाउट मेबी 1 or 2 एक्सेप्सन्स। है कि हामी कहाँ यो लागू गर्न गाह्रो छ। सेन्ट जेभियर्स कलेजमा मैले पढाउँदाखेरि म रेगुलरली होमवर्क दिन्थेँ। स्टुडेन्टले गरेर ल्याउँथे भने म हेरिदिन्थेँ, ल्याउँदैन थिएँ भने म डिमान्ड गरिदिन्थेँ र राम्रो स्टुडेन्टहरूले ल्याउँथे पनि। तर आई वाज इक्वली डिसलाइक्ड बाई स्टुडेन्ट्स एन्ड नट ओन्ली स्टुडेन्ट्स बट बाई कलिग्स अल्सो। किन? मैले होमवर्क दिएपछि कलिगहरूले गाह्रो हो। हामी कहाँ त हेलमेट टिचर छन्, होमवर्क हेर्ने फुर्सद कसलाई छ। त्यसैले हामी कहाँ साइकोलोजिकल ब्यारियर बढी छ, भयङ्कर छ, बढी मात्रै होइन। टेक्निकल एस्पेक्टहरू सोल्भ गर्न सकिन्छ र आई एम ग्ल्याड टेक्निकल एस्पेक्टहरूमा हेल्प गर्नलाई तपाईँहरू जस्तो स्पेसलिस्टहरू अलरेडी हामीसँग एभाइलेबल छन्। त्यसैले हामीले यो युनिभर्सिटी सिस्टम र म त अब स्कुलतिर आजकल अलि बढी ध्यान दिइरहेको छु। एजुकेसन मिनिस्ट्रीमा यो सब लागू गर्नु पर्यो। कारण एजुकेसन मिनिस्ट्रीमा राम्रो भन्छ, एजुकेसन मिनिस्ट्रीसँग इन्फ्रास्ट्रक्चर एकदमै राम्रो छ। देशमा करिब करिब 40 वटा उनीहरूको ट्रेनिङ सेन्टर छन्, मास्टर्स ट्रेनर छन्, सिनियर मास्टर ट्रेनर्स छन्। उनीहरूको कागजमा रेगुलर प्रोग्राम पनि हुन्छ। म सेकेन्डरी एजुकेसनमा हुँदाखेरि मैले यो सब आफैले हेरे पनि हो। तर त्यहाँ पनि प्रब्लम हाम्रो यो त्यही हो, के भन्दाखेरि कागजमा धेरै गर्ने, एक्चुअल वर्कमा नगर्ने मेन्टालिटीले हामी कहाँ बिग्र्या। अब पितृभक्तजीको क्वेसन एकदमै जायज छ, तर हामी आफै पनि यसलाई कसरी कतिसम्म पुश गर्न सक्छौँ, अब हामी नै लाग्नु पर्यो। हामीभन्दा माथिकाहरूलाई फोर्स गर्नु पर्यो, एक्लैले हुँदैन। दोस्रो, हामी कहाँ यो सिस्टम लागू गर्ने सबभन्दा ठुलो टेक्निकल डिफिकल्टी इक्जाम सिस्टम हो। हामी कहाँ फिलोसफीमा गडबड के छ, स्टुडेन्ट हामीहरू टिचरको लागि एजुकेसन सिस्टममा स्टुडेन्टले एजुकेसन किन चाहियो? लाइफमा जानलाई, जीवनमा राम्रो गर्नलाई। स्टुडेन्टलाई एजुकेसन किन चाहियो? पास हुनलाई। त्यो गडबडले गर्दाखेरि धेरै कुराहरू बिग्रिरहेछ। यही कमेन्ट थियो, तर लागौँ, बिर्सेर हुँदैन।
मैले पनि
सायद 15 दिनपछि आउने चुनावमा हामीलाई मौका छ। यो नेपाली अडियन्सको लागि म भन्दैछु, तपाईँहरूलाई त्यति मतलब कन्सर्न नहोला र हुन पनि सक्छ तपाईँहरूलाई पनि। बाइ द वे अहिलेको तरिकाले हुँदैन।
मैले पनि अघि सुरुमै मैले कमेन्ट गरेँ कि हामीले टिचिङ गर्दाखेरि किन यसरी मेहनत गरेर पढाउने, किनभने हामी टिचिङ गरिसकेपछि स्टुडेन्टहरूले जानोस् होइन, अनि त्यसपछि एउटा सेटिस्फ्याक्सन हुन्छ नि, त्यही नै हो हाम्रो गेन भनेकै। अब नेपालमा सरले भन्नुभयो जस्तै यो एक्जाम सिस्टम चाहिँ एउटा एकदमै चेन्ज गर्नुपर्ने नै हो। अनि अर्को चाहिँ एक्जाम सिस्टम भन्नाले अब एक्जाम अहिलेकै उसमा पनि बिस्तारै चेन्ज गर्ने हो भने एक्जाम पछि ग्रेड गर्ने, कापी जाँच्ने त हामी नै हो होइन। अब कोहीले यस्तो पनि सुनेको छु, ल्याबमा गएपछि कि 19 कि 20 होइन, आउट अफ 20मा 18 घन्टा दिनै हुँदैन, त्यसो भन्ने पनि हुन्छन्। अनि त्यसरी हामीले नै दिने हो, त्यहाँ दिने त हामी नै हो नि। नराम्रोलाई पनि 18 दिने हो, राम्रोलाई पनि 20 दिने हो, 18 घटी चाहिँ नदिने पनि हामी नै हो। अनि त्यसरी दिँदा अनि मान्छेहरूलाई चाहिँ त्रिभुवन युनिभर्सिटीले चाहिँ बेरोजगारको कारखाना हो, बेरोजगारहरू उत्पादन गर्ने ठाउँ हो भन्ने बेलामा अनि त्यो बेला चाहिँ हामीलाई बित्छ नि। त्यो चाहिँ मेरो विचारमा सबैले आत्मसात गर्नु पर्यो।
आइरोनी के हो भने त्यही बेला बेरोजगारहरू नै हाम्रा प्रधानमन्त्री र मन्त्री हुँदै गएका छन्।
यो दुर्भाग्य हो सर।
हामीले निम्ति आएको दुर्भाग्य हो। बाइ द वे
यो हामी यो फर्मल टकलाई यहीँ एन्ड गरौँ। थ्याङ्क यू सो मच मिम सर। यो रेकर्डिङलाई स्टप गर्नुहुन्छ कि